everyone. Welcome to this cross-cultural dialogue. We are going to talk about the database world from Eastern and Western perspective. Mm-hmm. We have the honor to have Mohan, who is the IBM fellow.
Retired fellow.
And you're a database legend from my perspective.
Okay.
You're a trailblazer in a lot of the transaction processing and database fields. And Charlie from OceanBase, who's the CTO of OceanBase. I'm Ming-Shu. I'm also the founder and host of the channel Ming Trio. So I think it will be a very interesting dialogue because, as Mohan mentioned, you have worked for IBM for 38 years.
10.5 years before I retired in June 2020.
And you kept being active in the database world. So you could
say
you have 40 years in the database
field.
Yeah,
because my PhD thesis was in the database area.
Yeah, and Charlie has 20 years and I have 30 plus years. So combined, we could claim that we have about, here you're looking at about 100 years of database experience talking about, the database nowadays, right?
Sure, yeah.
So let me start with Mohan. You have seen it all, from the beginning of the database, from the early stage of the transaction processing, from all sorts of things,
right,
till nowadays. Mm-hmm. I want to ask you, over so many years of database development, DBMS software development, what are you still excited about nowadays?
Oh, nowadays, of course, the support for things like hybrid transactional and analytical processing, HTAP, OLAP, and OLTP being combined. I had even worked on that a bit before I got focused on the blockchain space.
Oh.
Yeah. So for the last 5 years or so of my IBM career until 2020, I was spending more time on blockchain. Mm-hmm. But before that, I was part of the effort that was going on in IBM to make DB2, which was a row store, hence it was more of an OLTP system, become a hybrid kind of store with columnar as well as row, along the lines of what even SAP HANA did and things like that. So that stuff is still not a completely solved problem. In fact, when I looked at some of the suggested discussions that you had produced, Charlie, I was thinking I had not spent time on the distributed version of HTAP, which you guys seem to be seriously...
we have doing a lot of work in the HTAP of distributed database.
Right.
Yeah.
So even in the case of AlloyDB of Google, I don't think they've addressed it in the distributed context, because as of now, even in the cloud environment, they have one read-write node as a computation node, and the other computation nodes which might come and go based on the traffic and so on, the workload characteristics, they're all read-only nodes. So even though they allow you to have a distributed system, it's a very specialized kind of beast. It's not like the shared disk one, where multiple nodes can be all doing reads as well as writes. So that's one thing, but the latest, of course, is all this hoopla with AI for databases or databases for AI.
Right.
That area, even in the conference where we've spent the last many days, that has been discussed in keynotes as well as other presentations. So it's those sorts of integration of ideas from different areas within computer science that I would say is what keeps it going.
Right. So what about Charlie? What do you think is most exciting nowadays in the database world?
Actually, I'm very excited in the area of distributed database. This is what OceanBase is doing. And we have a distributed architecture. Then we can build a lot of good features such as HTAP, SQL plus AI, multimodal on top of our distributed architecture. I think maybe in China, the distributed database grows even faster compared to US.
Right.
Yeah, because in China we have so many people, so many engineers, so
The
many
scaling issues
Yeah, the
that come
scaling
from-
issues, and we have a Double 11 day. Yeah,
Right.
so the peak traffic of Double 11 day is much higher compared to Black Friday, and also when you come to China, maybe you can just use Alipay or WeChat Pay.
Right.
Although it may not very easy to use for you, but you can use Alipay to buy almost everything.
Right.
Yeah, you don't need to take cash. Yeah, actually, I think almost every business in China can be doing online.
Right.
Yes, but it results a lot of challenge in distributed database because it will bring us much bigger data and much higher concurrency.
Right. Number of clients will be high, and the availability expectations are also very high. Because the day-to-day simple things like paying for a coffee or whatever, you can't do if the system is not up and running and everything.
So in India, they use Paytm. Right?
Yeah. And
The-
Alibaba has got an interest in it, I think.
Actually, the underlying database in Paytm is ocean-based.
Oh, wow.
We found the source.
Yeah. In fact, I was looking at the latest hype cycle for data management or databases, whatever the exact
DBMS.
title is, that Gartner put out, and it had come out only in July. And there they talk about, why there is this need for distributed transactional databases, and as part of that, they talk about the point that you just made, how in the more mobile kind of environment now, that people that might be wanting access to a certain system might be all over the place. And by making it distributed as opposed to a centralized system, you can provide better response time by having some local nodes that are closer to where the end user is than having to route all traffic to a centralized place. But it's interesting how even eBay and such systems evolved, even Amazon and so on. To begin with, they were all highly centralized.
But I was curious from your point of view. Obviously, this is a symptom, or not a symptom, is a fact on the application side.
Right.
It's not dictated by the database technology. But why is that? On the surface, why only China has so many distributed transactions,
Well, actually,
while in the US or Europe or India or other places they are not?
So one of the reasons that Charlie was referring to was the fact that the scale is so much bigger here in terms of the size of the potential user population. That's one thing. Of course, the US has got 300 million people or so, whereas China is 1.3 billion or so. And of course, India's same story, right? We've even exceeded in India the Chinese population number the last couple of years. So this is all also related to this whole business of how much of online usage is there in a well-established, developed country versus in a country that is still somewhat considered as a developing country in the case of China, but India is still considered even more of a developing country. So sometimes the leapfrogging happens when you're late to the game. So I think the adoption of digital technologies has happened in a much faster rate in countries like China and much more recently in India. So now there is widespread usage of smartphones, and also the cost had to come down dramatically. So the cashless society business is more prevalent, I would say, in the emerging areas, emerging countries, than in well-established countries. So whether it's North America or even Europe for that matter. So I think that also changes the expectation with respect to reliability and scale and such, which brings in this business of having to use distributed database technologies. But there are other companies now in the Western side, like Cockroach DB, like Yugabyte and such, that are trying to mimic what Google had done for their own internal use, which was in the early 2010s, meaning 2012, that kind of time frame. The Spanner, highly distributed, highly available system, which made use of things like atomic clocks and GPS in order to provide what they call true time to order transactions. So, but it's somewhat limited. Originally, they were using it only within Google, and more recently with Google Cloud.
That's what I mean. It seems that they never really pick up as fast as, like OceanBase or other distributed databases are picking up in China. So what's your view from technology perspective?
Yeah, I think the user needs, user requirements drive the evolution of distributed database, like what you have just told. Yeah, for example, we have Spanner, we have Cockroach DB, Yugabyte DB, and all kinds of distributed SQL database, and also OceanBase. But maybe, for example, I used Sysbench, MySQL Sysbench, to compare the performance of MySQL and other distributed SQL database, including OceanBase. Yeah. Except OceanBase. All the other distributed SQL database, the single node performance is less than 1/3 compared to MySQL.
Wow.
But in OceanBase, it's a totally different story, because when OceanBase is used by Alipay, we need to process the workload on Double 11 day. So the user in Alipay always compare OceanBase with Oracle. Yeah, we need to be highly scalable. We need to be highly available. We also need to make sure that it's much more cost effective compared to Oracle. And
plus the response time also has to be interactive.
Yeah, and also response time. So I think if we have the requirement from the user and technology, we can do a lot of things.
Right.
So this is what we are doing. Yeah.
And you both mentioned HTAP.
Right.
That's a very, we're seeing something different from China's view versus sort of the global view as well.
Right.
HTAP is very popular in China, at least among the database developer or DBA's world, and also user space.
Right.
I want to hear both your views from Charlie's point of view. Why is so popular in China, and Mohan's view? Is it equally popular, or is it what stage it is?
I'd like Charlie to speak first.
Actually, I talked with a lot of our clients in all kinds of industries. Yeah, a lot of clients in China, they may don't know what is OLTP, what is OLAP. They just need a database. I want a database to process my workload, to process my data processing requirements. Yeah, maybe some query is simple, some query may be a little complex, but I don't care. I just need a database to handle my requirement.
So it's a very simple-minded way of thinking that they then say, you, the developers of the database systems, worry about how to give me this functionality.
Yeah. So, yes, I think the HTAP requirement is a natural need from the user's perspective. But actually, from the database developers' view, HTAP will involve lots of technical challenges, such as resource isolation, and we need to use one single system to make both the OLTP and OLAP performance very fast. It's not an easy problem. Yeah. So in OceanBase, I think we have a workshop yesterday, right? In OceanBase, we have some solutions. We are a distributed database. So as a distributed database, each partition, they have several copies. So we can use some copy to handle OLTP, as row store, and some copy to handle OLAP. So this is very natural. And then we can use SQL optimizer to load the request according to the query. So I think we have not solved all the technical challenge of HTAP, but we have already found a lot of use case which is suitable for combining both OLTP and OLAP together. Maybe for example, I think maybe for large companies, yeah, maybe they still have two independent OLTP and OLAP systems. Right. Yeah, but they will use HTAP system in some scenarios, such as like fraud detection, like user-facing, online analytics, user-facing online analytics, real-time analytics, and so on. But for maybe small and medium companies, a lot of companies they don't have lots of technical guys. Right. Maybe they want one HTAP database, that's which true. Should be much easier for them.
The way I also was just now thinking about it, this is yet another thing about how long a history have you had with any of this. Mm-hmm. So if the original idea was you have an online transaction processing system and then you have a warehouse, a data mart, and trickle feeding of data from the online system is being done via replication to this other one, and you've lived with it for a while. Now it's much more of a headache for you to combine the two into a single system and so on. So that might also explain to some extent why in the Western arena they might not be that eager to switch to a HTAP system, because it's going to change the way the whole organization and the way people have specialized their skills and so on.
Actually, there are also more and more systems like Google Alloy DB and like Amazon Sun database, and they want to both process two kinds of workload.
Right. Oh,
more and more.
I mean, it is evolving. It's just a question of whether in the West, are they adding HTAP features even to distributed databases, or they are still doing it only for more centralized database, or the cloud environment where, as I said before, it has the feel of the centralized because the read-write is only in one node and the other nodes are read-only from the disaggregated storage perspective, in which they have compute nodes that are different from storage nodes. And the storage nodes is where the persistent data is. And the compute nodes are the ones where you bring for short times data from the storage nodes, and they might get cached for a while, but ultimately the idea is that the compute nodes are memory-less and they come and go based on workloads.
Yeah, but actually the distributed database, I think it can do better than the centralized database in the HTAP workload. Because when you process both OLTP and OLAP in one system, the data should be bigger. Yeah, because
and
we
also
have OLAP
the whole
data.
business of row representation was a columnar representation. Yes. And the number of indexes you have and such things also changes a lot between. See, in the case of OLTP, you don't want to have too many indexes because then the response time for the transaction can become very high if you're synchronously maintaining those indexes. Whereas for the querying purposes, they can do batch-oriented updating of indexes as long as you're willing to tolerate a little bit of delay in when the new data becomes available. So, yeah, I mean, it is an interesting set of things that one has to deal with.
So we're also notice that nowadays, maybe related to the database technology changes, there are also more data models that are coming to the development world that people are using, comparing to what we used to only use normal form or star schema and those kind of things. Now,
so I think it's more due to, I would say, the use cases having more complexity associated with them. So especially when the social media revolution took off, the relationships between people and such became more important things to get modeled in the system. So there were, long ago also graph-oriented database systems, but they were more niche areas. They might have been used in CAD, CAM and such areas, but now even for vast volumes of data, that relates to social interactions amongst people, whether it's Facebook or LinkedIn or your equivalent companies like WeChat and so on. They are then saying, in order to be able to use database systems for storing such data rather than just the file system directly. Yeah. So as a result, they are saying now we need to extend SQL to even allow for graph-oriented processing to be expressed. And so there are now new standards that are being evolved, a more native graph query language, and then one that's an extension of the SQL language. And so, for instance, Google just announced what they call spanner graph, which is adding to this OLTP system, spanner, graphical way of doing the querying and storing data, where the relationships between the data are being represented conceptually, at least, in the form of nodes and arcs connecting these nodes.
Yeah, actually, in OceanBase, we are building multimodal features on top of our distributed architecture.
Right.
Yeah, we can support like JSON and like some vector and search functionality.
Right.
Yeah, we are doing an extension of SQL. We call it SQL Plus. Yeah, but we need a standard. By now, I think that is no standard in multimodal using SQL, right? So I think the advantage from the technical view, I think the advantage is that by building multimodal features on top of our distributed OLTP database, we can share the advantage of our distributed OLTP capability, such as stability, availability, scalability. I think as a database developer, it's very hard to develop a database which is stable because we need a lot of real business.
You mean the specialized kind of DBMS?
It's not easy to...
If you're going to start it from scratch, it'll be much harder to build in all these reliability and scalability features.
Yes, because we need a lot of business to test it, to verify it, and it will take for about 2, 3, or maybe 5 years.
Sure.
So,
in fact, interestingly enough, this has been going on in Google, for instance, for the longest time internally to Google. But now some of that is getting exposed. So for instance, I had a paper co-authored with Google people based on my little bit of consulting for Google, which was published in last year's ICD conference. This is the Firestore document database system, which previously used to use the file system directly or use something else that I've forgotten the name of. They then ported it to run on top of Spanner. So Spanner is a record-oriented distributed database system, right? On top of it, they are mapping this document model, and that leads to all sorts of strange contortions that you have to go through. But I think they did that because they wanted to benefit from all that nice lower-level infrastructural features.
The same low-level infrastructure has been proven to be very good.
Exactly.
When we were talking about different data models, and we talk about, some new database technologies such as vector, such as graph, are getting popular. There are 300 plus database vendors or companies in China, and each subsector you're going to see a dozen companies competing, and there are obviously different ways of implementing
some of these technologies.
For example,
new requirements.
Right. For example, like all these AI solutions, they require some kind of a vector solution, and there are different ways of implementing, a special purposed vector database versus a vector database tapped on existing OLTP database, for example.
It's interesting you are bringing
What's
this
your
up.
view?
Yeah, in fact, this got discussed in the conference we are at quite a bit. In fact, there was a panel on vector databases 2 days ago, I think. And the exact same points were brought up because even AlloyDB and Spanner and such, in the really recent past,
they're taking different paths.
they've added vector features, exact matching versus approximate matching and such things. Some technologies that Google had developed over a 15-year period in the context of search and so on. So they brought up these points, and they made the list of these special purpose vector database companies versus extensions of the already existing SQL systems.
Yeah.
The thing seems to be that really, unless you have some really stringent requirements with respect to performance and so on, you might not be able to justify going for a special purpose DBMS. It's far better to integrate some of these sorts of newfangled technology into the existing ones, because that way you won't have a dramatic difference between the APIs of the existing thing to which you have tacked on some of these newer features than going in for a special purpose DBMS. So
yeah, I also agree with you. I think the general purpose database with like vector plugin will be the future trend. Yeah, from the user's perspective, for example, I have had a general purpose database and it's very popular, it's very easier to use. The ecosystem is much bigger and we have lots of DBA who is very familiar with the knowledge. So why should I need another standalone vector database? Because I think the similarity search problem have been researched for many years in the database area, and the technical entry barrier of vector database is not too high.
Right.
So I see maybe general purpose database will be the future trend.
Yeah.
Yeah.
So so some of these sorts of things are also related to the point, for instance, in the case of Google, when AlloyDB came out, they also added to that the feature of columnar store as an optional way of representing the data. Unlike what Aurora guys did for PostgreSQL in the case of AWS, where they only addressed the row store, these guys tacked on this. But in addition, they also combined the functionality of Vertex AI, which is their machine learning oriented system, which is a separate system. They married that in a way with the relational database system AlloyDB by saying in your SQL statements, just like you have user-defined functions and table functions, you can also invoke Vertex AI calls. So it's those sorts of things that are also emerging trends with respect to marrying AI kinds of ideas into traditional database systems, all of which is arguing in favor of, as you said in your write-up, one size fits a subset of the requirements rather than one size fitting all, or one size doesn't fit all.
Yeah, I always said a lot of people they talk about one size fits all or one size does not fit all. I said that in ocean-based opinion, we think one size fits a lot.
Yeah, it was similar to Stonebreaker's,
exactly.
one size fits a bunch.
Yeah, fits a bunch. Yeah, very similar. Yeah.
So that's where inside of the DBMS, you are trying to leverage AI-like ideas, machine learning and such, and even here it got discussed in the last few days in a fairly lengthy fashion. Yeah. That's still an ongoing thing.
I guess it will take a couple of years to decide.
Sure, for sure. Then you can always do some very specialized thing and show in a certain environment how it works, but it's a long way from what worked in the lab to what works in the real world type of thing. Even the training of these models, a lot of the cloud vendors are saying they can't willy-nilly take any data that exists in their systems because the customers have some specific expectations of to what usage the data that they've entrusted with them can be made use of.
What about cloud? You know, a lot of Chinese database companies are moving towards the direction of what's called cloud native.
Right.
And I bet there are also
There are also lots of
globally.
discussions about these things. So in fact, I was even reading how some of these distributed database companies in the West are built in such a way that they are either cloud agnostic or they are capable of running on multiple clouds,
Right.
where even in a single installation of the distributed database, some nodes could be on one cloud provider's cloud versus another set of nodes being on another one, and some more nodes could even be in the on-prem.
Sounds ambitious.
Yeah, yeah.
Hybrid cloud. Yeah. Sounds ambitious.
Yeah, so even CockroachDB and such are talking about how their systems are already capable of doing this. So instead of so then the question is, are they using these different clouds only in a very simple-minded infrastructure as a service way, or are they in a cloud-first way developed systems where they leverage much more than just a container being used to run their software?
Yeah, or how low
Yeah.
you go, right?
Yeah.
On the
Do they even do
architecture
storage
stacks.
disaggregation and all this kind of stuff?
Yeah, at first we just moved our on-premise database to the cloud, and then we can make it cloud native or multi-cloud native. Yeah. Actually, this is what OceanBase is doing. We are doing
I mean, we
multi-cloud,
had this conversation in
hybrid
the
cloud.
workshop also on the first day, right?
Because you guys always claim the standalone distributed database.
Yes. Yeah, actually, I have just read a survey from Gartner. Gartner said that the cloud contributes for about more than 90% of database growth last year.
Right.
More than 90%. So every future database vendor should consider a lot in the public cloud. I think there are two kinds of public cloud database. The first one is cloud native database, like Amazon Aurora, like Amazon RDS. Right? Aurora is the cloud, Aurora DB, yeah. And another type is.
But they are running only on one cloud.
Yes.
That's the restriction.
Yeah,
right?
they are well optimized for the cloud infrastructure, but only for one cloud.
Right,
yeah.
exactly.
Another type is multi-cloud solution like OceanBase, like MongoDB, like Snowflake. Yeah, I think these two kinds of solution should coexist.
Right.
Yeah, and we find more and more companies they try to choose multi-cloud solution. Why? Because they want to avoid cloud vendor lock-in, and they want to need another cloud for disaster recovery. Yeah.
So in fact, one of the points I raised in this context was IBM spent a lot of money acquiring Red Hat, and the justification for that was that forever the world will continue to have some data in the on-prem, and also no one cloud vendor will take over the whole world. So the notion of hybrid cloud as well as multi-cloud is there to stay. But then Red Hat decided that to provide flexibility to the customer and not allow for vendor lock-in, they came up with this OpenShift layer. And they said, as long as the users of the cloud make use of the OpenShift API, similar in flavor to BAPL of SAP being used by the application program, they will do the mapping from their API to the API of the cloud that it runs on, in the case of Red Hat, or in the case of SAP, the backend DBMS that it is using at the moment. So my question to you would be then, why wouldn't you use the APIs of
cloud vendors.
Instead of doing that, why not use Red Hat's
like OpenShift
API?
Yeah, we don't use OpenShift in OceanBase. We just use Kubernetes. Yeah,
Yeah.
Kubernetes. OpenShift is developed on top of Kubernetes. So Kubernetes is also open sourced, and so it's very good.
But that's a more lower level thing. That's infrastructure
More
as a service.
general.
Generic.
General,
More general and more low level.
Yeah. So the higher level functionality that's provided within the layer in between is one reason to go for the APIs that Red Hat provides through OpenShift, right?
Yes.
So anyway, so there are all these sorts of, considerations and trade-offs and such that one needs to think about.
Right.
And the more you are embedded into the bowels of the cloud in a database as platform as a service, the more certain things will be cheaper or efficient or whatever compared to just using the bare bones version of the cloud.
Sure. Yeah, we after we migrated to the cloud, we also need to redesign the database.
Right.
For example, we use LSM3 storage engine in OceanBase. So after it's migrated to the cloud, we can move the compaction out of the process. And we can also do some useful features on the public cloud, such as serverless. Yeah, it's very useful.
Yeah, that's the sort of thing I'm hinting at when I say you are further getting into bed with the bowels of the cloud. The serverless has become extremely popular now, and I've spent a lot of time digging into that stuff.
You think that's the future?
Oh yeah,
absolutely.
Absolutely, no question, because all the vendors have done it already quite a bit.
Okay. Maybe we'll close our dialogue with a last question.
Okay.
Since it's very rare for you to come to China, what do you have as advice to the Chinese developers or DBAs, as in our audience?
Yeah, I mean, to some extent, I already briefly referred to that, which is this whole business of don't get carried away by the latest fad and things like that, but do your homework by looking at the history of how things have evolved and why they were done in a certain way and why they evolved in a certain way and such. Go around, and even if you're working on only as a developer, of a product developer as opposed to application developer, working on a particular system, don't think that you should only learn more about that one system, but go, attend meetups or whatever and learn about other companies' products and try to be knowledgeable about and keep abreast with the developments that are going on elsewhere. It will also help you if you lose your job to find a job elsewhere. So at various levels, various ways of looking at these things, there's a lot more to be gained by keeping your ears and eyes open to what's going on around you. And what else can I say? Yeah, I mean, also keep the requirements of a broader set of customers than the only to your country kind of customers' requirements and such, and learn English.
Learn English, exactly.
And,
I want to emphasize that too.
Improve your soft skills. It's not enough to be good technically. You need to in order for you to have impact, it's not just the technical stuff that matters, but also the passion with which you communicate and how you convince other people that your idea is a great idea and things like that.
Yeah.
So it's all these sorts of things, and also don't be in too much of a rush to get a quick return on investment. And so you should go deeper into technical ideas and sort of breathe and sleep and shower over ideas to really internalize these things, because it takes a while before
it's a long-term investment.
Right. Before you appreciate why certain things have been done in a certain way. Don't just go by reading the end result without understanding the logic behind how that end result was arrived at. So in my talks on career and all that, I go into some of these things, the do's and don'ts of how to be successful. Not that everything I did succeeded. So I talk about my failures also as to why certain things, even if the external community thought they were great ideas and they got papers written on them, I felt bad because they didn't see the light of day in terms of actually practically getting incorporated into products and being deployed and such. So in Silicon Valley, of course, people think that your job is done once your company goes public and you have a lot of money in the bank. But if you look at even some of the so-called successful companies of the dot-com era, there's not a whole lot to show as to what happened to those ideas. And so I would rather leave behind a legacy that's more in terms of long-lasting ideas and such than just lots of money in the bank, but whatever I worked on before is nowhere to be seen anymore. Because it was just a flash in the pan kind of thing, and you minted your money when things were hot. Thank you.
Yeah, thank you.
Really
thank you.
appreciate you giving me this opportunity. Thank you.
Thank you,
Charlie.
Thank you, Charlie.
Thank you.
Yeah. I think we'll close today's dialogue as it's such an honor to have Mohan and Charlie in the panel. And personally, I learned a lot.
Oh, thanks.
And
I
hope our audience share my view that hope you feel that this session is very valuable and come back to us in the near future. Okay?
Okay.
We say bye-bye.
Thank you. Bye-bye.